All right, so hi everyone. Today I'm going to be talking about 5 weeks worth of linear algebra in the span of 40 minutes and over the course of a couple modules. So there may be some oversimplifications and I guess lying to children. So to start, I want to thank UCLA Computational Medicine for giving us the funding to do this and to host all of our videos and modules online. And so to get into things, I wanted to talk about what is a scalar, vector, and matrix. Now, to start, what is a scalar? So a scalar is just going to be any number by itself. So you can think of this as a measurement, a value, or some magnitude. So how many fingers am I holding up? 4. So that's a scalar. 30. How many people are in this classroom? Things like that are just going to be a scalar, a simple number. Now, if we want to extend this and now think about multiple dimensions or a larger structure of numbers, we can motivate this idea of a vector. So a vector is just going to be a collection of numbers or a collection of scalars, you can think about it. So this could be, again, a container of measurements or values. And a key definition of a vector is going to be that it has both a direction as well as a magnitude. So I could tell you, in terms of direction, I'm riding a bike to the beach. And I could tell you toward the beach is my direction. My magnitude is going to be how quickly I'm riding my bike, so maybe 15 miles per hour. The way you're going to see this usually is denoted as a bold lowercase letter, V, or maybe a math script with an arrow over it. And this is just an example with a few random numbers in it from the previous slide. Now, a more concrete example, if you want to think about this in more of a less abstract sense, we can think about storing somebody, a person, as a vector. So say I wanted to collect a vector Mike, and I wanted to record some features about Mike. Well, I could ask him his height, weight, or shoe size, and I could store that in a vector. And the same for Brandon, for instance. And so here, what I've done to measure or capture some attributes for two people is I've asked them a few different variables or a few different measurements about themselves, and I'm now going to store it in a vector. So now, if I want to now talk about vectors in terms of a direction, so like we mentioned earlier, so people kind of often refer to these interchangeably as a direction or a vector. And you might ask, okay, well, what necessarily does that mean? So say I were to give you coordinate pairs, for instance, so x, y. In this case, we have 2, 1, and 1, 3. Well, I know that 2 and 1 in the left side of the coordinate pairs are going to refer to my x distance, so my distance from the origin, or 0, 0. So I can actually encode these as vectors, and I can say the top part of my vector, my first entry, is going to correspond to my x-axis direction and my amount of movement, and the bottom entry in the vectors are going to correspond to my y direction, or my up and down direction. So here in the blue, I've gone 2 spaces over to the right, and I've gone 1 space up. And where same with the orange, I've gone one space to the right and gone 3 spaces up. Now, if I want to kind of reify this and think about this in terms of real life, well, a direction, well, usually I think of a direction in terms of north and south or east and west. Does it make sense to think of vectors like that? And the answer is yes, we can think about things like that. So here I have my orange, and my orange is going to go north and south. I can scale my orange by -1 and maybe tell it to go down one space, and that could be interpreted as going south. The same logic follows for the blue. Blue could be going east and west. And so again, I'm always going to focus in this space as my first entry in my vector is going to correspond to my x space, and my second entry, my y space. An example of how you might see things in genomics research is in terms of being a SNP. So for a given individual or a sample, I'm going to get a vector that contains information about a few SNPs or a few loci that I've recorded. And here, for example, I have SNP 1, 2, 3, and some values for 2 individuals. Now, what is a matrix? So an easy way to kind of think about a matrix is that it's just an extension of the vector. It's now going to be what I get if I stack a few vectors next to each other. So now, if I before had 2 people, and I take them and I stack them row-wise, I now have this matrix that is people by measurements. And so this is going to be a common way we're going to see this in research, is that we'll have samples or individuals by features or variables. matrix. So what I mean by that is that the people correspond to the rows. So like before, I have my height, weight, and I have my shoe size. And in the columns, again, I have the same thing. So if I look at the first column, that's a vector of heights, and then the second column, a vector of weights, and so forth. And so a way you're probably going to see this denoted is as an uppercase bold letter or an uppercase math script. And so what we can also do is we can think about this in another way. So why have I organized it as a people by attributes matrix? Can I organize it the other way? And the answer is yes, that's totally fine. And so if you're given a matrix that's individuals by variables, how do I go about switching my matrix over to that variables by individuals space? Well, what I'm going to do is use this operator called the transpose. And now what the transpose is essentially going to be doing is it's going to switch the rows and the columns. So the rows become the columns, and the columns become the rows. Here in our example, what we see is that the people are now on the bottom side, and the variables, weight, height, and shoe size, are now on the sides. So we've switched the rows and the columns. And so again, in terms of what you might be seeing in real research, in genomics research, is you're going to see a genotype matrix. So like before, where we had individuals and the measurements of different SNPs at different loci, we can kind of put this into a matrix. We can stack these vectors next to each other. The way you're going to see this referred to often is going to be, again, a bold uppercase letter, G, or a math script letter, G.